Yeah, I'm making a UI library. Basically from scratch. I made a lot of progress. Started writing like more complex components for it. Like really got to like writing like tree views and text fields and stuff like that. And I want like a pretty robust text field. That's why I say it's like complex. Like there's a lot that goes into it. A lot of state management. Um, and just kind of got to the point where it's like okay, I kind of like brute forced it in the sense of just like, all right, I know the components, right? Like, I know how I want this to work. I have like a constraint solver. Um, I have like a 2D render pipeline. I have like a styling system. I don't actually have a quad tree. Um, but you know what I mean? I at least like have an API. Um, that I can use that doesn't actually like do anything a quad tree might do, but you know what I mean. I like all the pieces are there. I have like and I have this like pretty cool like sort of like declarative way of defining your like hierarchy, your view hierarchy. You start with your root, and then you know, you add some children. You say, okay, here's a row. It's very inspired by like Flutter and Swift UI, like feel wise, ergonomics wise. Um, but yeah, right now I'm rewriting the constraint solver because it's just the like this whole like expression thing that I had was like very very it there's a lot of like memory fragmentation and just like like I had all the expressions in this large buffer, but like they would like jump. You know what I mean? Like one expression would reference some other like sub expression that's like halfway across the buffer. It's just like what I mean. Like let's simplify it. Let's calm down. Let's like I'm trying to basically fit everything into like a nice flat buffer. Um, and yeah, that's what I'm working on right now. Um, I mean, I'm not gonna sit here and explain the whole thing, but you know, if you're interested, tap in. Um, okay, yeah. What am I working on right now? Okay, so how does this work? Like, I'm still trying to figure that out. Like the original version sort of was this. I mean, like I had this like object, or I had this class with some members and some functions, um, and I'm like, okay, like my friend wrote a bunch of like he kind of just like wrote the memory layer for our game engine that we're working on, which is part of, but it just had me thinking like, okay, like I like in this sort of like API and this sort of like I'm trying to like do write this in like a very like data oriented way. um uh this AP like this sort of like constraint solver program module should not care how like it, it is not this is responsibility to like actually like allocate memory. So like or decide how memory is like laid out. You can say, okay, I expect a buffer to be to have like certain elements in a certain order, but that's it. Like in terms of like how large should this buffer be, whatever. Like no. That's I think that should be somewhere else. I think that I'm pushing that off until I find a place where it makes sense to specify that. So all of these things, I mean, these things all need to be like pointers or references, or actually they don't, because solve context, there's like there's not any actual you enter into this module by passing a solve context. So the client at this point, like whatever client to this API is gonna like deal with creating this, and they can create it however they want. um so that's what I'm working on. I have this sort of stuff is like very like general for like the constraint solver. Like an in buffer is just literally like the it has like element you know, quad for like how it gets laid out, you know, location and size. It and quads can be, here, I'll just write this out. Uh it's sort of like this flat thing. So like I have a few like element types. I have like a box, I have a text, and I have a layout, and I have a root, which is literally nothing. Box is just like most things are boxes. Like just a term I've used on like other projects to represent sort of like ambiguous sort of like quad like things, but it could really be any shape. It could be rounded rect, like, you know, circle, whatever. Like the shader supports like a few different sort of like more primitive-y shapes, and ways to style it. But yeah, essentially it's a box. Text is just like text rendering. Layout is basically a box. Boxes have their own sort of like layout mechanisms. Layout is just has a layout mechanism. There's no like rendering logic, so it's just like it really only exists in the element hierarchy. And once everything is like, once the element hierarchy is used to then create a list of quads that then get rendered, these don't exist anymore, and root is just a empty element type that I don't think we actually need. It exists. I'm gonna remove it. I really think like you should just start off with a like I and hold on. There's it's like 1,000 sirens. Excuse me. Yeah. Sorry. Okay, so we have these like element types. I don't want to like tell the user how to like build their thing at all, really. So I don't really want to enforce like a root, like it's a tree, so it has a root node. You know what I mean? Your root node. If you want to make your root node a text, you can't add children to the text. There's no like function for that. So like, you know what I mean? Like like, okay, you know, a box or a layout are both perfectly fine. Like nobody like. You could you could have one box that everything's inside of, or you could have multiple, like, you know, micro, like, you know, smaller windows inside like a large context, whatever. Like, I'm not designing, like, you know what I mean? I'm not like Qt. I'm not like, I'm not trying to like marshal the way that you write applications. I'm just trying to be helpful, really. Again, sort of, whatever. Anyways, the buffer layout is something like this. So you get like element type, then you get each field of the quad. So what are some fields? You might get top, left, width, and height. Right now I'm thinking you don't have to specify them in that order. And so basically, like, before each thing, you would have like a field type, field data, field type, field data, field type, field data. Okay. Now, top left, so like, I'm just gonna call it field data. Now, field data, right? There's 4 fields, so you can specify the 4 in any order as long as all 4 are specified. Field data is an expression. So what you end up what ends up happening is it's in, what is it, reverse Polish notation. So you get like field data, for example, could expand to like like float, and then, you know, you expect like a float, and then you get some constraint that is, and like float, like I kind of have this like operation thing that it's like it could be a float, it could be, these are all constraints, it could be a constraint, or it could be an operation. And so you just read one of these and then you know what to do. So if you read a float, you expect to read the actual value. Then you can read like let's say it's like field type equals height here. And you want the height of this element to be 2 times the width. So you're reading field type height, then you get float, you get, you expect your float, and then you get your width. And so like we have this like argument buffer, sorry, right here. You get this argument buffer so you can see what, you know, keep track of arguments. Because, you know, there's some operations like, I think like clamp takes 3, and like theoretically, you know, we could have some sort of variadic thing. It's just like, I think it's like a pretty like robust sort of way of doing this, probably. I don't know, I've never really written anything like this before. I mean, I take that back, I really have, but nothing like, I wrote Chisel Lang last year, which is like a programming language for back when I was doing an anti-Blender bit. I thought I could write Blender. I thought I could like do it better. Never having used Blender, I was like, nah. Like honestly, Blender's gonna be so complex to use. I would actually rather like write a 3D modeler than actually use Blender, because I think it'll be faster for me to like write and implement. And then I was like, oh, and there's no mouse. There's no like mouse interaction. It's just code. You're gonna write Chisel Lang, which honestly I think the syntax is actually pretty elegant. I wrote a syntax highlighter. It was pretty cool. It was, you know, you get this sort of like I didn't do reverse. I had this sort of like AST like recursive sort of thing. It was not fast. I would not say it's fast, but it was fun. It was an experiment. You know, it was a failure ultimately. I have some pretty cool screenshots of it somewhere. Anyways. Field type is height, you get float, you get 2.f, and you get width, and then you might get some operation like multiply. Okay, and then also for each expression, you get an all right, we get field type for these particular expressions, but not all expressions have a field type because they don't all correspond to like a quad field, right? That would be silly. But all expressions do get an expression length. So as you add to this expression, as you build out this buffer, you keep a pointer or an index to like where your expression length is, and then just like, you know, keep adding, you know, however many bytes you're adding, and then like this is like the total length. This goes from float to multiply. So if you want to skip, if for instance, right, width is not like, let's say you have height defined here, then you have width defined here, and width is not solved yet, then you can't calculate this. So you have to skip and you have to go to the end of the expression and move on. And so like that's what expression length is really used for, is for like, okay, like so we don't have to specify, like, what's the other solution? Okay, dynamic expression, I mean these are dynamic, but like unspecified expression lengths, but then we have to have like an end token. Okay, cool. Why don't we just do like 2 extra lines of work and have an expression length at the beginning, and you can do a lot more with that, and it doesn't add space to your buffer. Like literally like an expression length I think is like a uint 16. We probably, well, yeah, I mean an end token would be like a uint 8, unless we end up having like more than what, 512, you know, if there's an unsigned like 8-bit, like unsigned short or whatever, unsigned chart, like it doesn't matter, push past it. It's okay. I like, it's really splitting hairs at this point. Gotta get some more coffee. Check out the mug, you know. Go believe you. Okay. So we have this. This is just like one example. This is sort of like a more specific example. And then, so you have your element type, you have your field type, you have all your fields, and then depending on the element type, right, you get a layout. And so boxes get layouts, layouts have layouts, layout elements have layouts. You know, the naming has a lot to be desired. I feel like every time I like explain this to somebody and explain what a box is, it's like that's not really like what people consider a box. Like a box is not a very like computer sciencey word. Anyways, we have layout. Sorry, lost my train of thought. Okay, so we have layout and layout. Like this is sort of what I'm planning on doing this session is like fleshing this out. Before that, I'm working on. I have this. Sorry, I have this concept of expression context that is something that I might want to have like a struct expression context or something like that. Just like keep it more organized like that, and then say like something like that. But right now it's only one field, so I'm not gonna do that. But it's like this stuff resets for each expression that we're evaluating, because this is sort of like a state machine. I don't really know. I'm not like a word. I'm not like a term guy. You know what I mean? But like this is like something that retains that, like, as you go through, as you parse this this buffer and create this out buffer of resolved quads, like you're gonna end up like all of this context refers to that. So like your stack is based off like where are you in your hierarchy. You know, if you're deep into your hierarchy, your stack is going to be large. If it's not, your stack's going to be small. These are the arguments you're building. It grows and shrinks. Like, you know, once you call something like subtract, it'll put your result into the first argument and then clear the rest of the vector. Like, you know, this is just sort of like a config sort of thing, but, you know, how many passes do you want this to resolve in? Or how many passes do you want this to like go for? Whatever. It is what it is. You know, if the constraints aren't solved, then you're gonna get broken UI. So it's a little bit up on whatever. This is just like the current current reserve quad that we're pointing to. The parent of the current quad. Again, I think like these names could probably be like fixed, but whatever. Okay, this is sort of the layout. I think I'm gonna keep this. I honestly tried to like I recorded for like 40 minutes this morning, and then it like stopped recording my screen like for like 35 minutes. So I'm like constantly like going back to like check to see like is it actually, and it's like, okay, yeah, it's recording my screen, but you know what is probably because I like open Signal, and Signal is probably like, yeah, nope, you cannot record this. I didn't open it on stream, to be fair, or not on stream, on recording, but I did open it like I still had the app open, and so I would assume that's what happened. But then I was like researching. It's like people have problems. Like, I don't know, whatever. Who cares? Whatever. If this doesn't work, it doesn't work. Okay. I'm locking in though, enough sort of like banter, like, you know what I mean? Part of the reason I'm doing this is to like hold myself accountable and actually get shit done. So let's do that. Let's start. Okay, that is the original one. Okay, let's start here. Okay, so eval quad field, we already know the current. So we could say ctx left. Anti-find and replace. That's not true. I really only use like find and replace like once I get to the point of like, okay, I need like a regular expression to like actually like do this. Otherwise, like doing this is not that. You know what I mean? It's not that bad. God, my old boss will always be like, yo, like you can never oh yeah, and I'm unemployed. But not not like my most recent boss like at that company. It's like my old boss from like 2-3 years ago, however long. But he was like, oh man, like never use an unscoped enum. And I'm apologizing to him because I'm using an unscoped enum, and it's literally just because I want to do like bitwise operations on it and like not have to like override every single operator. It's just like I'm sorry, like this is like, you know, do you want me to do this, or do you want me to do like, you know, define these as like const exprs, you know, like maybe define them as const exprs because they are on scope. So it's just like, what difference does it make? That actually might actually be the correct answer here. It's crazy how, like, I like earlier I had like a go-to, I was like using go-to. He also told me like never use go-to, like, so it's like, you know, it's like a cardinal sin. It's sort of like the first, you know what I mean, like thou shalt not use like go-to. And like I found a use case for it. I was like, you know, trying to break from a switch statement and have some sort of conditional logic that like happens before I return from the function. I'm like, okay, well, how else would I do this? Would I break this into like two functions and then return a certain value and then do something based off that value? Oh wait, yes, I would. I literally would, and that would literally be like easier for a compiler to optimize theoretically. Again, I'm not a compiler. I'm not like a compiler, man. I compile. You know what I mean? Like I compile. I'm not a compiler, man. Um, I'm not. You know what I mean? Like I press the button. I press the play button. I press the build button. It's not gonna work right now. Um, so I'm not gonna press the build button right now. I sometimes press it. um. Okay. Okay. What? Like, I keep getting sidetracked. I keep like, you know what I mean? All right. Infinite recursion. Infinite recursion. Okay. Actually, that's a really good point. Oh, cause see, this is the function I split into two different functions, and now I have like I love this guy. Like evals a, you know what I mean? Anytime you get a chance to write a function with the name eval, like, you know you're doing some cool shit. You know what I mean? Like eval, that's hard. That's like Lisp. You know what I mean? That's like you've written like a, you know, you're writing a language. You're writing bytecode. You know what I mean? You're writing something that can be evaluated. You know what I mean? Like you spend your whole life getting evaluated by other people. You know what I mean? You know, did I get an A? You know, am I good enough to get into college? Like, am I good enough to like whatever? No. I'm evaluating you now. You know what I mean? I've become sort of the. Ooh, what in the shit happened? Okay, like I'm the evaluator, right? That's kind of hard, but because we don't need this argument because it's part of the expression context, which is owned by solve context. I need like a good name, and this is the shit. This is like the stupid shit I get like hung up on, where it's like, all right, so what's this one doing? This is sort of like the eval. Like I hate like do eval. I hate that shit. I hate when you have like a verb before a verb that doesn't add any, like, you know what I mean, like eval impl. Is that wrong? Am I wrong for that? This is like stupid, like stupid object oriented bullshit, like creeping into like my like I mean, it's not functional really, but it's like, you know, I'm doing like an anti OOP grift, so I'm grifting. I usually hate having. Yeah, I'm gonna keep that separate. I it's just like I like to have space. Like if they don't start with the same thing, like I really would love to have like that. Cause look how beautiful that looks. But like these have to be done in a certain order. Whatever. Alright, I'm gonna have eval impl. So be it. We don't need to do that. So look at that. This function is literally just a while loop. ctx dot in buffer dot reader dot offset is less than ctx then expert end. Great. ctx shit on the log Okay. I'm sort of like anti-shorthand for that because it's like, okay, well, what is in? You know what I mean? But maybe maybe I should have like some member that is just like a friendly little thing. Okay. I don't think any of these other things are reading. Arg buffer just needs. See, here's a fine replace. We need ctx.arg buffer replace. Replace. Yay. Okay. Where's this function? That just needs ctx. And what's all these? Oh, cause I'm gonna do ctx.current pointer, and then parent dot. I think I could just do this for all. Well, I'm not gonna do it for the whole file. That's the issue. I have like the old implementation in here, and I guess I have. What's this to do? To do lookup resize function and see if it works as expected. Fair. Anything embarrassing? Let's see if I'm working. It is working. Okay. You could tell, like, I don't, like, you know what I mean? I got this computer when? It's a year and a half old, and Cookie Clicker from like 2013. Like, you know what I mean? iOS 9 icon pack. Like hack this site. Hack any paid. You know what I mean? Like, these are my favorites. Excel, like Laravel, like export. Booksmart. That was the first startup I ever worked for. It's not even called Booksmart. Booksmart.slack.com. Yeah, it's nothing. All right. Oh, it's files. Is it even there? Nah. That's stupid. What am I doing? I wanted to stood vector resize CPUF. Resize verse resize change vector capacity stl, because like I understood that. Okay, then whatever. Then yeah, we want to resize to 1. I mean, this, like, honestly, like, these things should all be resized to 1, even though it should theoretically be only one thing. I think this is probably not going to be any slower, and it might be faster. I honestly don't know, but either way, it's like the intention's very clear. And like when you're writing stuff like this, when I'm writing stuff like this, like I need to be able to like be doing something completely different, come back in here and be like, oh shit, something's wrong with the height constraint. Okay, if it is unresolved or yeah, if it's unresolved, we don't have any value to give it. If it is resolved, we are going to use the value that we have. Okay, easy enough, right? Okay. I think we should write some tests. We still good? We still good? Yep, we still got the screen on. All right, let's write some tests. Let's see what happens. Solver.test.cpp. I'll leave the at, and then I'm just gonna like do one of these. But really, we just need I don't think we actually need gmock. Paradigm slash v2 slash constraint solver 2. How do we start a test again? I'm actually such an idiot. Like this is like kind of pathetic. All right, I'm just gonna use these expression tests to. Oh, and I'm gonna copy and paste that. See, I like, why write code? I'm just kidding. All right, so solver v2. I mean, really it's v3. Because there was actually an original version of Paradigm that was really bad, but that's what we built like our first like scene editor and physics sort of like thing with. Whatever. This is, I mean, you know what I'm saying? You live and you learn. We're trying to do a lot in a little amount of time. All right, so solver v3 addition. No. What we are going to test? What are we going to test? We're going to test. Let's test addition. What? Oh wait, no. This is like far more complex than addition. Let's test. With resolution. I don't know. We'll end up having to like. I don't know. All right, so we need a solver context. I like curly braces, and I hate that that's not the autocomplete. CTX dot inBuffer dot. Oh wait, I think does buffer auto reserve for me? Okay, only if I say so. Let's just do it explicitly. InBuffer dot data dot reserve. I don't know, not too big, right? OutBuffer dot data reserve. There's no data function because it's literally just a vector. I think reserve takes. I'm pretty sure reserve just takes the number of elements. Yeah. And so if we say a quad is 20 bytes for 96 divided by 20, let's say 200, whatever. Our buffer.reserve, let's reserve like 6. Dot stack.reserve. Let's do a nice. Let's do 16. I like that's actually pretty high, I think. Okay, so we have all this stuff reserved, which probably we could extrapolate this outside to reuse this stuff. Now we want. Okay, so now we actually need to write to this buffer, and this is gonna get undone. But let's see. What do we first expect? We have a buffer. What's the first thing that we read? Well, we read. Sorry, I was just checking levels. I'm just trying to, you know what I mean? Okay, what's the first thing that we read? We read why I'm like crashing. I was full of jokes this morning too. I just can't believe I like messed it up. But you know, you live and you learn. Yeah, gotta keep a smile about some shit. Unemployed and everything. I'm playing. I mean, I'm not. I am unemployed. I do not have. Yeah, if you have a job, I'm playing. I mean, you know what I mean. It is what it is. I'm trying to enjoy this. You know, I'm trying to enjoy this free time. All right, and do something with it. I feel like I'm doing something with it. Okay, so with resolution, what in the hell am I doing? Okay, I need to know what the first. Okay, so right, we're reading element types. Okay, so ctx.in. Let's do one of these. Auto w equals ctx.in buffer dot writer. W dot write. See already like this name is stupid because it's like in buffer. We're writing to the like. Why don't we just call it element buffer? You know what I mean? Or like element tree, like whatever. We're writing element type box. Let's say w dot right. That's like the main one. Yep, we have eval quad. Okay. Alright, so we read element type, then we read element depth. Right stood uint 8t 0, right? 0 depth. I don't see any other reads. Okay. Then we go to eval quad. We should just call it eval quad field. So we need a quad field. Okay. Let's say write quad field. Let's say we're evaluating width. Let's say height. Let's say width because we're evaluating width. So width is going to be based on height. That's what we're going to do. So we're going to write first. We're going to write quad field height. Then we're going to do w.write. Now we're writing an expression, but we need the length, and the length is a std uint 16t, which I don't know yet. So we write op float, and we say we write let's say it's 100. So we write a float, and we say size of op plus size of float. Okay, that should be it. Now we need width, and we're gonna fix the size in a little bit. Let's say our width should be 2 times our height. W.write op multiply. I think that's it. And then we can just say we need op plus. Let's do one of these. Oh wait, wait, should I be doing it like that? Okay, yeah. Size of op. Again, like this stuff is like a client is not writing this stuff out. This is literally just because I don't actually have an API for like adding to this yet. Okay, so we have float, we have op float, op or op is really what it is. We have op float op float op. Okay, great. And then we probably want quad field left let's do one, or well, I hate one. Let's do 5. Obviously nothing's gonna like render here, but let's test to make sure all of these values are set the same. Okay, so what are we testing for? Expect equal ctx dot out buffer dot size is 1. Okay, const auto quad equals ctx out buffer. Let's get the first one. Expect equal ctx dot, or wait, quad dot, oh wait, float, right? Quad dot, what's the first one we set? Width is 100. Let's see, will it fill it out? No, it will not. And top should be 10. Okay. If I one-shot this, that is going to be crazy. I have not tested any of this code. This is all brand new code that's being tested. The only thing that I've tested and used before is my buffer class. And you saw that. That doesn't what? Buffer reader. What? It literally, you know what I mean? Ready? This is a pretty big test. This is not like a this is like a, I hope everything works and like something might be fucked up but the output, you know, matches. Like I'm not like, oh, like is, you know, testing to see if getting the size is the right. No, I'm not doing all that, and I'll tell you why. Because like am I gonna sit here and be like, oh, like it's not reading this field correctly? Like, first of all, no, because the client is not writing this. Users are not writing this. This is gonna be abstracted. So like I'll test the API that writes this stuff, but I'm not gonna be like, oh, like write this UN16 in here and then read, like, you know what I mean? Like, no. Okay, ready. Moment of truth. Run. Is it even gonna compile? Should I debug it? Nah. Ooh. Okay. Let's try that again. Okay, flanking. Oh. What happened? What in the... What? I've never seen this side. What? I'm not... What? I'm not running this test. What in the... Okay, wait. Okay. I'm commenting out literally every test because... is this... Okay, so solver test, campground test. Boom. Done. Okay. Now you can't complain. Sometimes I just don't get G-test. Okay, well, it didn't crash. It didn't... Ooh! Okay, this doesn't count as an attempt. This doesn't count as an attempt because what am I testing? I'm testing solve, right? Did I call solve? No. Wait, what? Oh, CTX. Yeah, I didn't call solve. It was really... I didn't call solve. All right. Okay, got Sigma board. All right. Let's debug this. What's happening? Ooh. What's happening? Hey, okay. Stack is empty. Why? I added something to it. Are we at the beginning? No, we're not. Oh, wait. Yeah, that's 2. Probably that's 2. Oh, no. These are both U8. So, okay, so that should be 2 bytes. All right, so that's right. So we've read 2 bytes. J is at last element depth is 65. Element depth. Oh, wait. Wait, what? Let's see. I can't follow. Why would that ever be 65? What? They both start off as 0. And we've still read... Okay, we haven't read... Okay, so now we've read... Alright, so they're both 0. Stack should be 1. Let's catch it if it goes out. Okay, so last element depth is 0. 0 minus 0 is 0. So the stack should be empty. We should call pop back. Okay. Okay, so something horrible happened. Something horrible happened. It's cool. It's cool. We'll figure this out. What's the element type that we got? We got box. Okay. Okay. Do we make it to box? There's no like continue. Okay. Let's go into here. Well, let's go into here. What field are we evaluating? Height. I think that's right. Yep. Okay. And now we want to eval height. All right, so what is expression size? It should be 8, so it should be size of OP. Jesus Christ. I mean, it's 1. So it should be 5, right? Size. Huh. That could be messing it up. Size of OP. Why is it reading 8? It should be just 1. Okay. Well. Let's run that back, cause my heart is a room with no cameras in it. Okay, that works. We may want to put that back to not just 1, but I don't see why the default for an enum class would be an int. What? How many enum classes have? Does that make sense? Like, am I being like what? That makes no sense. Okay. Maybe it does. I do not know. There's so much I don't know. I really don't know most things. I really want to finish this. I really want to lock in and make this freaking stuff happen. Okay. Okay, so if we're at 10, I guess presumably that's where we are. Okay. My heart is a ruin, no cameras in it. Okay, so solver, we should have already added something here. Left top width height. Oh, I forgot about z index. Okay, that looks good. And then we should just return this. And we came from here. And so res is going to have a value. And I'm just curious to see if we actually are at... Wait. Because that is probably the problem. Shit, okay, hold on. If we were at 10, if we're at 0, we're reading the first byte. We're right before the first byte. If we're at 10, we have to read byte number 10, 11, 12, 13, 14. Shit, we might have to do something like... Do we have to call like a line of or some shit? But if we're at 16, and we read a float, and we read an op. Hold on, I need to run this. I need to run it again. Also, wait, let's see what happens. Oh. What in the hell? Okay. All right, let's try this again. Did I not put a... Oh, wait. Yeah, let's run this again. Okay. Sorry. Jeez, I'm going silent. I'm going silent. I need to fucking figure this out. This is some bullshit. What is going on? You know what I mean? It's like everyone can write code like this. Everyone can you know what I mean? I can sit here and explain how all the data is laid out, and then it's just like, yeah, but shit, you don't even understand your own code. Like, you can't even... Okay. So the current context is 10. It ends at 15 because the size is 5. 11, 12, 13, 14, 15. But 15 should be the end, so it should be 10, 11, 12, 13, 14. We're still reading from 10. So we read OP. Can we do size of tie UI v3 OP? Okay, 1. So then what happens? It's at 11. Size of float is 4. Then it should be at 15, but it's at 16 because of alignment. Okay, so we do have to do the alignment thing. So we do have to go back here and say size of OP. We have to say align of oh wait. Well, we're not gonna okay, actually, you know what? I'm okay with this because here's the thing: we're not actually calculating. We can hard code this. We know because this is 1, we're gonna add 1. This I don't know, but actually, you know what? Might as well just do it now. We might as well say stood uint 16 0. We might say okay. Expert size equals w dot. I mean ctx dot in buffer dot data plus dot data plus w dot off what's that gonna give me? Am I being stupid? Okay, it's gonna be a byte point. Okay. And then we can just do like static cast stood uint 16t star. That's not gonna work. Maybe we do a reinterpret cast. Okay. Alright, so it's a uint 16 star expert size. To memory that has not been written to yet, but that's okay. Now, well, it might not be okay. Let's just call it a ledger, and let's say w.buffer.size. Let's just use ledger here. Okay. And then we write. Okay. So just this is all this similar logic. Then we say ledger I don't think we can dereference it yet. I think we just have to say I mean, we could just do that, right? We could say pointer and then if we don't even need the size, why don't we just say maybe we just store the length here. Maybe that makes sense. Like maybe we just store, like I don't want to touch it right now. I want to get this working first, but maybe we don't even need to do this like extra addition. Like maybe we can just store the last, like, you know what I'm saying, skip 2. What's like how like not how many bytes do I need to skip, but like what index do I skip to? Like this could be it, but it's not. We have to do ledger, but and that should be there. Okay, I'm gonna see what this produces. This is gonna freak out. This is gonna freak out. Oh, expert size is 8. Oh. W.buffer.size. I think this is what it should be. What happened? What happened? Expert size 6. Okay. This should be the first one. Expert end is 16. Okay. Okay. I'm okay with that. I'll copy and paste this for now. So we got height. And we get width. We don't need to redefine these. Am I like, how do I I don't even want to put this on the internet, but whatever. What do I do? I say I have a int star x. How do I store 5 in x? Okay, you can literally just. I'm stupid. I'm so stupid. I can't. I should not. I should be put down. I should be put down in a bad way. I should be put somewhere. I should be tortured. No, I shouldn't be put down, because what I should do is I should have to live with the fact that I just searched that up and now it's part of public record forever. Yep, that's what I need to do. Anyways. Slap. I gotta get some juice. I'm slowing down. Okay, expert size can be that as long as we do that. Okay. I actually am pretty embarrassed about that. That is just like embarrassing. Boom. Okay. Then we want to say that, and we want to say it for here, and then once we're done, and you could be like, oh well, you're going back in the back. Well, I'm not going that far back. Maybe I'm wrong for it. I don't know. Maybe there's, you know what I mean? Like, whatever. All right. Let's see what happens here. Let's run this. See what I mean? Like, okay. So first one should be 100. Second one, expert end should be the same position as offset. Okay, so we're not doing anything special there. And then res should obviously be 100. Okay. We multiply our buffer, and then once we resize it, it should be 200. I'm just gonna skip through that. Oh, because we're doing it 3 times. For fuck's sake. Let's do 1 iteration for now, and let's make sure all these things are getting set properly. Solver.test ctx at max number of iters equals 1, because that is a good point. It did catch something. I do build the out array as I go, and I'm okay doing that, but like it should only be happening on 1 iteration. Okay, so we set height, and we set width, and we set left, and we set top. Quad dot width is 200, quad. Left, top, width, height. Let's run that again. Why is it? So first we set height, which is 100. Okay, that makes sense. Then we set width, which uses height. Let's just skip that one. We set the width to 200, and the resolved mass should have also width. So current should be width is 200, height is 200. Okay, and just to make sure, width is 200, height is 200. Okay. Left. Why is left 200? Yeah, then I guess we once just evaluating a single expression, so there's no recursion. I mean, we could probably just call it clear. All right, let's try that. Should pass our tests. Sorry, I got hyped. Is the test wrong? Yeah. I'm so stupid. Right? Width should be 2 times height. Yeah. 1 test passed. Can I run it in debug and without? Yay! 1 test passed with Stop playing with me, bro. Get shit done. All right. I'm out for now.